Welcome, my name is Dr. DrWedding, and this is DrWedding DC12. Opens, shunts, and shorts. In this video you will learn about an open, a shunt, and a short, and how they change the way a circuit works. Let's start by defining these three terms. An open is when there is a break in the circuit. One way to understand a break is to replace it with an infinity ohm resistor. A shunt is an intentional low resistance path in a circuit that bypasses some or all of the components. A short is an accidental low resistance path in a circuit that bypasses some or all of the components. Electrically, a shunt and a short are exactly the same, but they have a different connotation. A shunt means it was intentional, a short was a mistake. First, let's investigate an open. An open is a break in the circuit. It might be an accident like a broken trace on a printed circuit board, or it may be intentional like a switch that opens and closes. In this example, the open is intentional, it is a switch. Now think of the current like cars on a highway. The red cars are driving from the positive terminal to the negative terminal, and the yellow cars are driving from the negative terminal to the positive terminal. As they start to drive, the cars run into a drawbridge that is up. The cars stop, and there is a traffic jam, so all the cars in both directions come to a stop. If we create a table for this circuit, we can start to fill in some information. Assume the resistance of the open switch is infinity. We can calculate the total resistance. Infinity plus 500 ohms is equal to infinity. There is a traffic jam in this circuit due to the open drawbridge, so we also know that the current everywhere is 0. Using Ohm's law, you can then calculate the voltage drop across R1 and R2. Because the current is 0, the voltage drop across both resistors is also 0. To find the voltage drop across the switch, we would need to multiply infinity times 0, but this is a problem. Instead, we can find the voltage across the switch using Kirchhoff's voltage law. The voltage across the switch is 10 volts. If you think about it, this becomes obvious. The path from the positive 10 to the top of the switch is marked in red. There is no current and no resistance, so there is no voltage drop. All of the red section is plus 10 volts. The path from the 0 volts to the other side of the switch is marked in yellow. There is no current, so there is no voltage drop across the two resistors. All of the yellow section is 0 volts. So the gap produced by the open switch has 10 volts across it, and the red side of the switch is the positive side, and the yellow is the negative side. So, the easiest way to think about an open is that it takes 100% of the voltage and passes 0% of the current. The explanations and the calculations were done so you could understand what is happening with the open. But a circuit with an open can be reduced to 4 simple rules. The current in the series circuit is 0. The voltage drop across each of the resistors is also 0. The voltage drop across the open is equal to the supply voltage. And the resistance of the open and the total resistance are infinity ohms. These rules can be applied to any series circuit with an open, a break, or a gap. Now let's investigate the shunt and the short. Electrically, a shunt and a short are the same thing, so one example will cover both terms. Most of the time people use shunt to mean an intentional bypass. If someone says short, dead short, or short circuit, it usually implies that it was an accident. The circuit below is a series circuit, and you should be able to fill in the table next to it. The circuit has been solved, and the table has been populated with the values. The path the current is taking has also been highlighted in red. A wire has been added that bypasses R1. This is the shunt. A line on the table has been added to store the shunt information. The shunt in this example is a wire with 0 ohms of resistance, so this value is added to the table. Because the resistance of the shunt is 0 ohms, 100% of the current will go through the shunt, and 0% will go through R1. The new current path is shown in red. Note, in this video the shunts will be 0 ohms, but in later videos the shunt will be another resistor and the current will be divided between the two paths. Because the shunt is 0 ohms, and because 100% of the current is going through the shunt, this means the current through R1 is 0. And using Ohm's law, you can see that the voltage across R1 is also 0. The shunt has no resistance. Using Ohm's law, the zero resistance, and I total, we can calculate the voltage drop across the shunt. Anything times 0 is 0, so the voltage drop across the shunt is 0 volts. The total resistance can be calculated by adding up the resistors along the path the current is taking. The total resistance is the resistance of the shunt, plus the resistance of R2, plus the resistance of R3. Because no current is passing through R1, it is not included in the total resistance calculation. The total resistance is 500 ohms. At this point, this problem becomes a series circuit problem. First, you find the total current. The next step is a bit different than the series circuits we discussed earlier. The current is the same, but only where the current is flowing. In this example, the current in R1 is still 0. And, of course, Ohm's law can be used to find the voltage drops across the two resistors that have current flowing through them. The shunt will remove a resistor from the circuit. The shunt will remove the resistor it is bypassing from the circuit and the table. There is no need to include the shunt on the table because it is just a piece of wire. So the simplified solution is shown here. The rules for a 0 ohm shunt are the opposite of the rules for an open. A 0 ohm shunt has 0% of the voltage and it passes 100% of the current. Here is the same circuit, but the shunt has been moved. You may wish to pause the video and see if you can solve the circuit. When you restart the video, the path the current takes will be highlighted and the table will be filled in. The shunt has bypassed R1 and R2, so only R3 is in this circuit. The current path has been highlighted. The bypassed resistors have been removed from the table and the remaining information has been filled in. Here is the same circuit and the shunt has been moved again. You may wish to pause the video and see if you can solve the circuit. When you restart the video, the path the current takes will be highlighted and the table will be filled in. The shunt has bypassed R2. Only R1 and R3 are in this circuit. The current path has been highlighted. The bypassed resistor has been removed from the table and the remaining information has been filled in. Here is the third and final practice problem. It is the same circuit as before and the shunt has been moved again. You may wish to pause the video and see if you can solve the circuit. When you restart the video, the path the current takes will be highlighted and the table will be filled in. The shunt has bypassed R2 and R3, so only R1 is in this circuit. The current path has been highlighted. The bypassed resistors have been removed from the table and the remaining information has been filled in. I hope this video has helped you understand the difference between an open, a shunt, and a short. And I hope you understand how each of these will change the circuit. If you find these videos helpful, please like the video, leave a comment, and subscribe to my channel. This is the only way I can continue to make these videos.